Hello, this is Mr. Huff, and I wanted to very quickly go over stellar evolution. And this is in the classroom presentation that you can go back and review and make notes if you wish. The life cycle of an average main sequence star begins as a nebula, proceeds to protostar, then it becomes a main sequence star, then it expands as a red giant, then it becomes a planetary nebula, collapses and becomes a white dwarf, and finally cools off to become a black dwarf. For high mass stars, the first three stages are exactly the same. It begins as a nebula. The material comes together to form a protostar. It becomes a main sequence star, but these stars are more massive, more on the massive side, and they become super red giants. Remember on the HR diagram, that's that line across the top. When they get to the end of the supergiant stage, they become a supernova, basically exploding. And one of three things will either happen. The core will be dispersed, and that's the end of the star at the supernova stage. If it is about 1.5 to 3.5 solar masses, then it could form a neutron star, so the lower mass, and if it's above 3 solar masses, it's probably going to collapse and make a black hole, where the escape velocity exceeds the speed of light. This is a data table that will help you understand the different temperatures. For instance, the main sequence stars, they rate a temperature of 5,000 to 15,000 degrees Celsius. And they are 1 to 1,000 times as bright as the sun. Then we get to the giant stages. You can see that the temperatures decline to 3 to 6,000 degrees for the red giant, or 4,000 degrees for the super red giant. And the red giants are between 100 and 4,000 times as bright as the sun, and the super red giants are 100,000 to 1,000,000 times as bright as the sun. Then the final stages of the main sequence stars of average mass are the white dwarf and the black dwarf. And the white dwarf, you can see it's pretty warm at 8,000 to 15,000 degrees Celsius, but they're also very dim because of their size, so 0.01 to 0.5 times as bright as the sun. And then when those cool and become black dwarfs, they're 2,500 degrees or less, and they are basically nowhere near as bright as the sun. And then there's some information here about the different stages. So the slides with the yellow on top are about average mass stars. Okay, stage 1 for all stars is nebula. Stage 2 for all stars is when the nebula collapses and heats up and forms a protostar. And then stage 3 is when the interior temperature reaches 15 million degrees Celsius. And then we have fusion begin happening in the middle of the star. Now we have a true star. This is where the main sequence stars originate. And so there's some information here. Then the next phase is the red giant phase. I'll give you a moment to absorb this information. The fifth phase of a average star, it goes from red giant to planetary nebula. So this is when the fusion in the center of the star begins to diminish, and it can't retain that outer layer, so it just kind of spreads out. Then it becomes a white dwarf with about 80% of the original core of the star kind of collapses in on itself. It continues to burn for a while, and then it eventually runs out of energy and becomes a black dwarf. Massive stars start the same way. You begin with the nebula, and then it forms a protostar, and then it forms a main sequence star, exactly like an average star. However, they're large. So whenever they start running out of fuel, then they become the red supergiants. And these are an interesting difference here is they tend to expand and contract several times, and they begin generating heavier elements like the alkali earth metal, magnesium, and oxygen, the non-metal. Then something terrible happens. They go supernova. So basically they collapse on themselves and explode. And I think it's an interesting little factoid here. The actual supernova shines brighter than the entire galaxy for a short time. After the supernova occurs, one of three things will happen. Either the star will be dissipated, scattered thither and yon. If it's between 1.5 to 3 solar masses, it will become a neutron star. And if it's above 3 solar masses, it's probably going to become a black hole. And that is a brief overview of stellar evolution. Thank you for listening and watching.